Good morning, everybody. I hope you're doing well. I hope the homework treated you well. We did those 6 problems in class, and I got very few questions on those. And so then I gave you these 9 additional problems, 3 from each section. And so I'm just going to dive right in. I'm only going to look at those 9 problems because, like I said, I didn't get many questions about the 6. The one thing I want to point out is even me, I look at these, and when they don't come out clean, I'm real quick to think that I must be doing something wrong. But sometimes you just got to follow the math and relax. On this first one right here, the most that I can factor out is a 2z squared out of each of these. And that would leave me with 2z to the third minus 5 equals 0. And remember, we said before that if we have something times something else and it equals 0, then one or both of those things have to equal 0. So I set them equal to 0 right now. I say 2z squared equals 0, which would mean that z squared is equal to 0 over 2, or 0. So therefore, z squared is 0. So therefore, z is equal to plus or minus 0, which is, of course, 0. Now, I didn't have to show all those steps. I'm just trying to make sure I'm not losing anybody. Okay, the other part, you say 2z to the third power minus 5 equals 0. Well, you push the 5 to the other side, and you get 2z to the third power equals 5. Divide both sides by 2. You get 5 halves. And then at this point, you can just take the cubed root of both sides, okay? And you say z is equal to the cubed root of 5 halves. Now, there's no plus or minus, because with the cubed root, or with every odd numbered root, cubed root, 5th root, 7th root, the sign will stay the same. If it was a positive, it'll remain positive. If it was negative, it'll remain negative, okay? We just have a problem with negatives under even numbered roots. Okay, so those are actually my 5 values. There are 2 0 values, and there's 3 cubed root of 5 halves values. But those are my solutions. Okay, moving on. I got x to the 5th plus 8x squared. I'm going to take out an x to the 3rd out of both. X squared out of both of these, and I'm going to get x to the 3rd. Let's see here, plus 8 equals 0. Now this is good because I don't know if anybody realizes this, but this is a sum of 2 cubes, so I could factor it further, but I think really I'm going to end up kind of getting the same thing, so I don't know that I really need to go there. But so at this point I go, well, I got 2 things multiplied together equals 0, so therefore either x squared is 0, which would mean that x is 0, or x cubed plus 8 is 0, which would mean that x cubed is equal to negative 8. And it's okay to take the cubed root or any odd root of a negative number. And so because that is negative 2, because negative 2 times negative 2 is positive 4, but times another negative 2 would give me negative 8. So there's your solutions, 0 and negative 2. All right, for number 13, this one looks way more like a quadratic that we're used to, but to get it there, we have to take out an x first, and then we would have x squared minus 5x plus 6 equals 0. Now, at this point, it is a quadratic. So we go, what are the factors of positive 6? That's sum negative 5, and that's negative 2 and negative 3. And so now we've got 3 things multiplied together that end up being 0, so we have to set them each equal to 0. So we say, well, I know that either x is 0, or x minus 2 is 0, which would be to say that x is 2, or x minus 3 is 0, so therefore x is 3. So you get 0, 2, and 3. Okay, next section. Now we're looking at the radicals. Okay, these radicals, man, these are simple problems. With the all these polynomial problems, the big thing, remember, is setting it equal to 0. With the radicals, it's always about getting just the radical itself on one side, all by itself. Nothing else over there. Look at number 41. It's got this 1 over here. We got to get rid of that, okay? But so on number 39, it's already over there by itself. So the first thing I do is I just square both sides. When I square both sides, I get x plus 2 equals x squared. That was really simple. Now you bring everything over to one side. So I'm going to bring all this over to that side. And when I do that, I will have x squared minus x minus 2 equals 0. And so now we're looking for factors of negative 2 that add up to be negative 1. And the factors of negative 2 that add up to be negative 1 would be negative 2 and positive 1. So I have x minus 2 times x plus 1. And with that, I set those each equal to 0. X minus 2 is equal to 0, so therefore x is 2, or x plus 1 is equal to 0, so that would mean x is negative 1. All right, moving on. Number 41. Already mentioned this, got to get the radical by itself. So the first thing we're going to do is I'm going to bump that 1 to the other side, and I'm going to have 2x plus 1 equals x minus 1. Square both sides, and you get 2x plus 1 is equal to x minus 1 squared. Remember, you have to FOIL that out. You can't call that x squared minus 1 squared. You can't do that, ever. Okay? So this becomes 2x plus 1. If I FOIL that, Think about it. I mean, you picture like another one right here. You go, okay, that would be x minus 1. You can do first times first and outer times outer. And so first times first, you give me x squared, outer times outer, negative 1x, inner times inner, negative 1x, and then last times last, positive 1. Okay, now I've got to pull everything to one side or the other. I'm going to go ahead and bring this stuff over there so that way I don't have a negative x squared term. And I've got x squared. Let's see, now I'm going to have minus 4x, because I already have minus 2x on this side over here, and then I'm going to subtract another 2x. And then I've got a positive 1, but I'm going to subtract 1 from both sides. So I'm just going to get this equals 0. So that makes it pretty simple. So all you have to do is factor out an x, and you're left with x minus 4 equals 0. So either, at that point, either x is 0 or x minus 4 is 0, which would be that x is 4. So those are my two solutions. X is 0 or x is 4. Now, with radical problems, remember, we always got to go back and plug those answers in. And I skipped that on the first one. And look, I'm sure that I made a mistake. We go here on this first one, and we plug that in, and we get 2 plus 2 is 4. Square root of 4 is 2. And x is 2. So that's perfect. But then when we plug this one in, we get negative 1. Negative 1 plus 2 is 1. The square root of 1 is 1, but it's supposed to equal this value, this negative 1, and so that can't be. So I'm sorry that I didn't point that out already. In my hurry, I moved past that. That's not an acceptable answer. So the only answer we have is x equals 2. On this one, we got to check them. So I plug in 0. If I plug in 0 right here and right here, I would get 0 plus 1 is 1, square root of 1 is 1, 1 plus 1 is 2, and 2 does not equal 0. So this cannot be a solution. I plug in 4, and I get 2 times 4 is 8, plus 1 more is 9. The square root of 9 is 3, and I'd have 3 plus 1 equals x, which is 4, and that's true. Okay, so this is a solution, but not x equals 0. All right, last radical problem. Not that this one is any harder, but I would probably do a little bit more moving and shaking on this one. I'm going to put this over to this side and then bring the 3 over to this side. I don't know, just to keep things easy. And so I'm going to have x minus 3 equals, I have to add that square root of x minus 1. Square both sides, and you get x minus 3 squared is equal to x minus 1. Foil that out, and you get x squared minus 3x minus 3x plus 9 equals x minus 1. And now I'm going to bring all of this over to this side so I can set it equal to 0. Arrow's taking up a lot of room. So I'm going to get x squared. I got negative 3x, x, negative 6x. I'm going to subtract another x, so I get negative 7x. I got a positive 9, and I have to add one more. So I have plus 10 equals 0. At this point, you can factor that. Factors of 10 that sum negative 7, that would be negative 5 and negative 2. If those equal 0, then you have x minus 5 is equal to 0, so therefore x is 5. Or x minus 2 is equal to 0, so therefore x is 2. So here's my two possible solutions, but remember, with radical problems, definitely plug them back in. So I go back up to the top here, and I get, let's plug in that 2. If I put a 2 here, and a 2 here, under the radical, 2 minus 1 is 1, square root of 1 is 1. So then I get 2 minus 1, which is just 1, not 3. So this does not work. Okay, plug in the 5. 5 minus 1 under the radical is 4. Square root of 4 is 2. 5 minus 2 would be 3. So we like this answer. That's good one. All right, home stretch. The last 3 problems. These are all the quadratic type. Excuse me. So these are the kind that we might want to use like a substitution. So here, I look and I see that I have, this is basically the same as x squared minus 13x squared plus 40. So here's this thing, okay, that keeps showing up and makes this kind of look like a quadratic. So I might say, well, let's let u equal that x squared. And if that's the case, then u squared would equal x to the 4th. And so that means I'd go u squared minus 13u plus 40 equals 0. Now, what are factors of 40 that add up to be negative 13? Well, negative 8, negative 5. So I get u minus 8 times u minus 5 equals 0, which would mean u minus 8 equals 0, so u is 8, or u minus 5 equals 0, so u is 5. And then I got to go back and resubstitute. So I get x squared is equal to 8, meaning that x is equal to plus or minus square root of 8. And x squared is equal to 5, meaning that x is equal to plus or minus square root of 5. And I could simplify this one down a little bit more and say plus or minus 2 times the square root of 2. So those are my solutions, okay? All right, number 53, again, a quadratic type, almost identical to 51, realizing that I could set u equal to x squared, and I would 2u squared plus 4u plus 1 equals 0. So then I'm looking for factors of 2 that add up to be 4, and there are none. So believe it or not, I can use the quadratic formula right now. I couldn't when it looked like this because this isn't a quadratic, but this one is. So then I get u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get u is equal to negative 4 plus or minus the square root of 16 minus 8 all over 4, which would be u is equal to negative 4 plus or minus the square root of 8 all over 4. Okay? And so that's what x squared is equal to. Ugh, what a mess. Okay? And now all I have to do is, this would be really cool. If you look in the back of the book for this one, it'll say no real solutions. You can be like, well, wait a minute, why not? Because if you plug in x squared equals this, here's what I need you to see, and I'd love it if you guys saw this. You've got a negative 4 here. Even if you add square root of 8, square root of 8 is less than 3 because 3 squared is 9. Even if you add the square root of 8, you're still going to have a negative number, okay? And you can't have x squared equal a negative number. So that would mean that x is equal to plus or minus the square root of some negative number. All over 4, what a mess. Okay, and then if you have negative 4 and you subtract the square root of negative 8, you definitely have a negative number. And so that's why the back of the book says no real solutions. And this is a good one that I'll agree with them on that. I said, let's go get all solutions, but this one's pretty crazy. All right, and last problem. This one right here, we're going to say, let's let u equal x to the third. So therefore, u squared is going to be x to the sixth. All right. We're going to have u squared minus 26u minus 27 is equal to 0, which could factor down to u minus 27 times u plus 1 equals 0, which would mean that u minus 27 is equal to 0, or u is equal to 27, or u plus 1 is equal to 0, so therefore u is negative 1. Resubstitute, and you get x cubed is 27, or x cubed is negative 1. At this point, take the cubed root of both sides, and x is equal to the cubed root of 27, which is 3, or x is equal to the cubed root of negative 1, which is negative 1. And those are my two values, 3 and negative 1. I hope this helps. I hope you have a great day. We're going to work through some other problems and get you there. Have a good one.